Hi there, Mrs. Lindquist here. Today we're going to talk about special right triangles. The first special right triangle that we're going to talk about is the 45-45-90 triangle. So here's my 90-degree angle. This is 45, which would lead this angle to also be 45, since we know there's 180 degrees in every triangle. So what is important about the 45-45-90 is that the two legs are congruent. So they are the same length. So if both legs are length S, then the hypotenuse will be S times the square root of 2. So let's write that out over here. So if our legs are length S, then our hypotenuse will be S root 2. So an example of that would be if this side length happened to be 10, we could get our other side lengths because the other leg would also have to be 10, which would make our hypotenuse 10 times the square root of 2. Find the missing side lengths exactly, rationalize denominators. So here we have a 45-45-90 triangle. So we know that these two side lengths are congruent. So let's label our ratios. We have S, S, and our hypotenuse is always going to be S root 2. Okay, so can we figure out what X and Y are? Well, we know this side right here, our S is equal to 3. So that is going to help us out now because X is also going to be length S. So that is going to be 3. And Y is going to be S root 2, which would be 3 root 2. So if they're asking us what X is, I would say X is equal to 3. That's my other leg. And Y is equal to 3 times the square root of 2. This is approximately 4.2. which definitely seems reasonable since the hypotenuse is the longest side. But for these problems, you are going to write your side lengths exactly. So let's take a look at two more examples of the 45-45-90. Again, I always label my legs as S, S, S root 2. So what do we know in this example? Well, we know that the hypotenuse of 4 is equal to S root 2. So that's gonna be what I'm gonna have to solve. So S times the square root of 2 must be equal to 4. So now I'm gonna solve this for S. So to solve for S, I'm gonna divide both sides of my equation by the square root of 2. So S becomes 4 divided by the square root of 2. So here's where rationalizing the denominator comes in, because we can't have a radical in the denominator. So to get rid of square root of 2, we would multiply by another square root of 2 in the numerator as well. So we're going to have 4 square root of 2 over square root of 2 over square root of 2 becomes square root of 4, which ultimately becomes 2. And then we look at this and we say, well, hey, wait a minute. I have 4 divided by 2, so I can reduce that to 2, or 2 over 1. So S becomes 2 times the square root of 2. This length here is going to become 2 times the square root of 2. And this length right here is also going to become 2 square root of 2. So in this particular example, X and Y, the two legs, are congruent. So I can just say that X is equal to Y, which is equal to 2 times the square root of 2. And that would be my answer for the missing leg lengths. Okay, I want you to pause this video and try example C, and then we will come back and talk about it. Okay, so you should have labeled your legs as side, side, and hypotenuse as side root 2. So what are they giving us here? They're giving us our leg. So we know that S is equal to 3 times the square root of 2, which would make this bottom leg the same thing, 3 times the square root of 2. And what about our hypotenuse? Well, that is s times root 2. So we know that s is 3 root 2, so we are going to substitute that back in for s. So for s, we're substituting in 3 root 2, and then we're timesing that by root 2. So that's going to give us 3 times root 2, which is root 4. So 3 times 2 is ultimately going to give us 6. So in this problem, my hypotenuse, which is x, is going to be 6. And y, one of my legs, is going to be 3 times the square root of 2. Okay, that's a wrap for 45, 45, 90. Watch part 2 for the 30, 60, 90. All right, see you soon.